Hello everyone, I am Luis Gutierrez from University of Guadalajara, Mexico. Today I am going to present our work, Numerical Investigation of Urban Head Island within Variable Porous Urban Domain. This research developed with Dr. Nestor Garcia and Dr. Juan Disea from University of Guadalajara. To introduce the context with the rapid population growth, the natural landscapes are replaced by an infrastructure urban. So this leads some physical phenomena. One of them is a urban head island, UHI. As you can see in the figure, the temperature in the city are higher than surrounding rural areas. To model to the city is very complicated because the geometry are complex and computational excessive. So for this reason, we adopt the methodology of porous medium. As you can see, are very similar. In the porous medium, we have two phases. The solid phase representing the buildings, and the fluid phase represent the streets in the cities. We are interested in formulating a system PhD to replicate the urban head island dynamics, and we consider the solar radiation the energy source. And we explored the impact of the urban morphology and the wind, and exploring one mitigation strategy. We used a model, a CFD methodology, adapt in the porous medium. It's like equation 1I. We found the term mass acceleration, pressure, Darcy-law correction, and the buoyancy term. The buoyancy term is become by the Boussinesq approximation, and we can see the air like incompressibly fluid. For the head transfer model, we formulate a system PDAs. For the fluid phase, we consider the TI temperature, the temperature of the air. The 2B is the surface temperature, like denoted like T0, and 2C is the fluid phase, representing the temperatures of the buildings. It's classical diffusion advection equation. This slide representing the schematic of the physical model. We assumed the wind blow to the left on the right, and the boundary in the inlet is like exponential profile, and the outlet we considered do nothing conditions. And in the ground phase, we have no sleep condition, and the tops and zero Newman condition. I used to say only K elements for the numerical solution. To the VDF model, we used a classical splitting method called IPCS method with a VDF2 implicit chain. We adopt the Taylor-Hood polynomials, P2 for the velocity, P1 for the pressure. We added the stabilization Galerkin-Lesch square. For the head transfer model, we used a standard finite elements, and we introduced stabilization streamline of Petrov-Galerkin. Okay, to characterize the urban, if we note in the most population cities in the world, the most dense the buildings are high rises are concentrated in the center of the city. For this reason, we introduced the Gaussian distribution for the represent the porosity, and with that we can describe other parameters like albedo, or and others. We used the methodology station data for the radiation to adjust the data along the day. And these slides show the results of the temperature arc along on the 24 hours. You can see in the temperatures accumulate in the urban domain as a radiation and decrease along during the day. I want to show you one video. In first experiment, we considered a city 400 meters and heat dense in the buildings. No, you can see how the temperature increase for the radiation and origin some eddies, and we can see the head is recirculates in these eddies. Okay, thank you. And the second experiment is we explored the impact of the wind in this model. In the two first pictures, you can the wind load. In the second ones, wind heat. The wind actuates like a air-warm transport. This is implicated during the day, the temperature transport surrounding areas. And the third experiment, we explored one strategy mitigation strategy with the albedo, with modifying this parameter. This strategy is adapt the technology with white roofs and the gray scaled or black roofs. In the first picture, you can see the heat value, the low values of albedo. In the second one, the heat values with the concrete or the white roofs in the city are significantly different in both. Some discussion about this research. We can formulate, reflect the UHI behaviors, adopt the porous medium is a key factor to simulate the impact of the city. We want to replace the stabilization of the momentum equation, and I would like better or time needs optimization of my code. This is some reference, and I would like to thank you to the Flats and Steel and the Elements Institute at Sorbonne University for the travel award to attend this conference, to the cities for my monthly doctorate scholarship, and for the travel expense for my University Guadalajara. And I want to say thank you for the attention.
Thanks, Luis. We have some time for questions. Any questions? Yes.
What do you mean by monthly doctoral scholarship?
It's
It's a joke, I guess, but
payment monthly.
Yeah, you get
for support me in my PhD doctorate.
Any other question? Yes.
Okay. Thank you. I was wondering if you plan to validate the model against some experimental data in the literature, maybe, or I assume you have many physical parameters that
Yes.
you need to select. So can you comment?
Yes, the parameters are take the literature, but the validation is it's a process because what is the how to represent the porous medium in the city. So with a student in the master, we formulate with data of the company in Mexico. We can formulate one mesh to contain the porous on the city of Guadalajara. It's in the process, but we can do that. I will.
There was another question here first, yeah.
Thanks for the presentation. Just, I'm not quite sure, but did you have any problems with the stability?
Yes.
Solution? Can you just explain a little bit on that and what you did to fix it?
Yes. For the momentum equation, I introduced the first one, the Polymon's Taylor-Hood elements. Is the first one, and the second one, I try to use the sub-stabilization, but it's expensive cost for the computation. For this reason, I use only the Galerkin-less square. Is add only term in the formulation. In the temperature of the air, I use the all residual of the equation, like a sub. I don't know if responds your question. Maybe in the later I want to show the software demonstration, and we can talk more about that.
There was another question there.
That would be also sort of my question. I mean, you're using an sub-stable Taylor-Hood space for the velocity and pressure, but still you're adding a GLS stabilization. Is that sort of mandatory in this problem or optional, just to increase stability?
In my first experiment, I don't include the GLC stabilization, but I have trouble in my solution. For this reason, I added it. Yes.
Any other question? I was wondering about the size of your problem. So how
Yes.
big the city can be and how big it is in terms of like the size of the system that you're solving.
Yes. I don't understand if you're
you're representing the city and the rural area. So how big it is like in reality? Is it like how big the city can be? And how many like elements it represents, like in terms of?
I don't know, but I consider it in this experiment 11 kilometers.
Okay.
Times to 800 meters, and the city is centered in the 5 kilometers and around all of the.
Yeah, so it's mostly like if you would compare with like some real data, that would be for like small cities.
Yes.
More. Yeah, that was my question. Yeah.
Sorry.
Yeah. Thanks.
Yeah.
Thanks again for the nice talk.